Hello, I welcome you all in this presentation related with the subject fundamentals of the manufacturing processes, and we are talking about the metalworking processes. Among the metalworking processes, I have already talked about the rolling process, and today I will be talking about the another important process which is called forging. This is a very important metal working process which is used which is of the great commercial importance because it is extensively used for making the variety of the products which are extensively used like crankshafts for automobile, then connecting rods, wrenches which are used for assembling and disassembling purposes, crane hooks. So, there are so many components which are made of by this forging process, and the advantage is that it improves the mechanical properties and results in very sound and the dense products. So, improved mechanical properties as well as the pores and inclusions etc. if they are there, they are closed and homogenized. So, it improves the density and the soundness of the products which are made by the forging process. We will go through the first through the basic approaches which are used in forging process, and thereafter we will talk about the different types. So, basically in this one the pressure, which is mostly the compressive force, is applied in metal. So, it flows or deforms plastically. So, the metal flows suitably either in die or in open space. If it is the die, then we get the impression or the shape which is desired, and if the flow is in open, this is called open die. In that case the flow is to be regulated through the controlled manipulation of the metal deformation in order to get the shape which is desired. There are two broad categories or broad approaches which are used in the forging processes, and these are called the drawing out and upsetting. So, in the forging, whenever there is a plastic flow of the metal, depending upon the way by which this desired shape is being achieved by the application of the force, we say it the drawing out or the upsetting force. These are the two broad categories. In case of the drawing out process of the forging, basically the metal cross sectional area is reduced and the length increases. So, basically the job elongates in during the drawing process, and so here like the job is like this. So, if we are either applying the hammers continuously like this, so the section is reduced and the length is increased in this manner. So, this is one case, or we can apply the force through the ram directly onto the plate which is of the larger thickness, and after the application of the force the section thickness is reduced and the length is increased. So, basically the cross sectional area is reduced and the length is increased. So, if we see here the force applied, the application of the force is here perpendicular to the direction of elongation or flow of the metal or flow of metal. So, like this piece is subjected to the force in this manner with the help of the ram or the open die. So, here it compresses and reduces the thickness and thereby increases the length. While in case of the upsetting, just reverse happens, and in case of the upsetting, the flow of the metal or the plastic deformation increases the cross sectional area at the cost of length. Basically, length reduces and increase in cross sectional area takes place. And another thing, the force is applied along the length of the stock or the job. So, to understand this, if the job is like this in the beginning with the application of the force perpendicular to this, the length is reduced this manner and increase in diameter takes place. So, this is what we can write like this also, like significant reduction in length and increase in diameter. So, initially if the diameter was di and this the increase in after the upsetting, this increase takes place with a significant increase in the diameter. So, this is what is called the upsetting, and the force is applied in the direction of, in the length direction of the job. So, these are the two broad categories. So, actual forging processes may be either singly or in combination, be using and the flow of the metal, either the drying out or the upsetting may be achieved, or a combination of the both can be used for achieving the desired shape and the size of the component. So, they are depending upon the approaches or the methods being used, the forging processes are categorized as Smith forging, drop forging, press forging, and machine forging. So, Smith forging, I will talk one by one about all these types of the forging processes. Smith forging is basically like the blacksmith, which in villages earlier, this is the traditional method. Blacksmith used to heat the metal stock, and heated metal stock is repeatedly beaten to manipulate the flow of molten metal, so as to get the desired size and shape. So, here the controlled manipulation of the metal by beating the hot metal using the hammer, which is mostly manually operated. So, hammer is used to beat the metal so that desired manipulation is achieved. So, one typical the process which is called fullering in Smith forging process wherein over the anvil, say this is the anvil having the hole in which the fuller is placed like this over the anvil, and so this is the lower fuller, and over this like this. So, another fuller is placed here like this, and the metal is beaten with the help of the hammer in this manner. So, basically the stock is placed over the lower fuller, and this is the upper fuller, and the hammering is done of the upper fuller, so that metal flows in the length direction. This reduces the cross section and increases the length. So, in this way what we get, basically we get the stock with the reduced thickness and increased length. Obviously, it will have the fuller marks. So, in order to smoothen the surface, in order to flatten the surface, basically the flattening is done so that all these the fuller marks can be taken care of, and the reduced thickness can be achieved, so that required cross section can be achieved. If you see, the control of the flow of the metal due to the impact of the hammer is important, and that need to be manipulated very carefully, and therefore the shape, the final size and the shape of the product which is obtained through blacksmithy largely depends upon the skill of the blacksmith, how carefully and how properly he manipulates the flow of the metal due to the continuous impact of the hammer. That is what is regulated in order to achieve the desired size and the shape. So, for this process, blacksmith process, smith forging process, the skill of the operator or skill of the blacksmith is important. Another thing is that this process is good for the small volume, means when few number of the products are to be made, not for the very large volume, because if you have to make very few number of the products, then making the die will be a costly issue. So, it will be important that instead of you making the die for making few products, better to use the smith forging process, so that it can be made economically. The another process for forging process is the drop forging process. In a smith forging process, basically the flat surfaces are used, so the flow of the metal is not confined in particular place, but it is open for the flow the sidewise. So, that sidewise flow of the metal is regulated in such a way that we can get the desired size and shape, while in case of the drop forging, closed dies are used. So, here according to the shape of the product to be made, we will have to make the die like this. This is the upper die, and say this is the lower die. So, this will be placed over the table of the press, and here we will be placing the stock or the material like this. So, basically with the help of the press, this is the lower half of the die and this is the upper half of the die. So, after placing the metal between the dies when they are open, now upper die is now the force is applied through the upper die onto the stock until the die closes. So, here the force is applied in repeated manner means 3 to 4 number of the impacts are applied onto the stock with the help of the upper half of the die, so that the die is closed. Once the die is closed, we will be getting the product of the shape like this. So, this will be the product. This may not be the final product. So, in order to get the final product, we may have to make the number of the dies with the gradual change in the shape. So, for that purpose, a systematic procedure of shaping using the forging die is used, since it uses the number of impacts in the drop forging. So, whenever the impacts are used in the drop forging, the surface layers gets deformed more as compared to the. So, this is the upper surface which will be experiencing the impact of the upper die, and the lower surface will also be experiencing the impact of the upper die, and because of these impact forces, the metal will be flowing sidewise to occupy the cavity in the die. So, more localized deformation basically takes place near the surface layers, both upper and the lower surfaces, and therefore, a very jarred surface is produced, and the surface is much harder than the material in the interior of the job. So, if you measure the hardness at the center and measure the hardness at the top, then more localized deformation will be taking place near the surface layers as compared to the interior portions, and that is why there will be heterogeneity or non-uniformity in the properties. So, the deformation actually is not uniform through the depth and through the thickness of the stock in case of the drop forging. Now, I will be talking about that if the shape is a bit complex, like in case of the Smith forging where the flat surfaces were there by and large. So, manipulation of the metal due to the impacts was more important, but here since the die is closed, so more complex shapes can be produced in the by the drop forging process. But to produce the complex shapes, even one set of the dies may not be enough. So, the number of the set of the dies with the gradually changing shapes are used, and for that purpose basically certain steps are used. These steps like fullering, aging, then bending, blocking, finishing and trimming. So, purpose of all these steps, because say for making these somewhat complex shapes, we need to follow certain steps depending upon the geometry of the product to be made. So, fullering actually is used for reducing the cross-sectional area close to the cross-sectional area required in the job. The second is this aging is used to to have the required quantity of the metal in the product. So, basically whatever is the amount of the metal desired in the final product, that is what is reduced in the aging process, and that is what is limited to the requirement in the bending as per the shape of the product. Here the bending or the bending is performed so that we can reach closer to the with respect to the bending we can reach close to the shape which is desired. And in the blocking it is the first major shape change is achieved as per the requirement, as per the requirement. So, this is basically the semi finishing step. So, for finishing purpose, after the blocking, when the major change in the shape is achieved as per the requirement, the final size and shape is achieved in the finishing stage. And then the last one is the trimming. If there is any extra material left at the flash, so the flash is removed in the trimming steps. So, these are like say 5-6 number of the steps which are used in the drop forging for achieving the complex shapes, and for each step the separate the die is used. So, that is what we can see with the help of this diagram how it is realized. So, if we see here, these are the steps of the forging, like fullering, edging, bending, blocking, and the finishing, and finally the trimming. So, these are the steps which have been shown schematically here. This is the raw stock, and the raw stock is first of all brought to the desired cross section by the fullering process, and then required volume of the material for the final product is achieved in the aging steps, and then as per the shape the bending is carried out, and after the bending we do the blocking, and the blocking helps us to get the shape closer to the shape which is desired, and then finishing will help us in getting the final size and shape. And once the final size and shape is achieved, the extra material which is left can be removed with the help of the trimming. So, these are the different we can say the steps which have been shown. The first one is for fuller, then edging, and then the blocking, finishing, bending. So, the different the dies are used for each step, so that in sequentially the desired shape and the size can be achieved. Now, if you have to compare, a comparison on the comparison part I will come later, because I need to talk right now first about the press forging. So, now we will take up the press forging. Press forging also uses the close dies, means there is a upper and there is lower die, and the metal is placed between the upper and the lower dies. So, after the application of the pressure, the die is closed and the shape is desired. So, like this is the upper die, and this is the lower die, and the raw material is placed between the two dies like this. So, what we do, in the earlier case repeated means in the drop forging repeated impacts were applied through the upper die, but in this case continuous increasing pressure performs the squeezing action. So, once the pressure starts to build up, the upper die is moved continuously until the dies are closed. So, the metal is closed, metal is basically squeezed between the two dies, and when it is squeezed, it flows within the cavity and follows all the profiles which are there, so that there is continuous flow of the metal to fill fill up the various cavities and the features which are there in upper and the lower die. So, here in this case the important features like closed dies are uses closed dies and continuous squeezing pressure is used, and when the continuous pressure is used in one go the metal takes the shape of the dies on closure, and during the squeezing action the deformation of the metal is uniform through the thickness or throughout the depth. So, deformation of the metal is uniform through the depth or through the thickness. So, more homogeneous flow and uniform flow of the metal takes place under the pressure conditions, and more smoother surface is generated. Okay. So, more smoother surface. So, here we can say the more smoother surface is generated in the press forged products as compared to the drop forged products. Since it applies the squeezing action by increasing the pressure continuously, so the kind of pressures which need to be used for the press forging, a kind of force which is to be used for press forging is very high. So, the force required for press forging is very high, is higher than the drop forging, and which is sometimes 2 to 2.5 times of the press capacity than that is needed for the drop forging. So, depending upon the kind of the size of the job, the press forging is used. Since the force required is high for the press forging, and therefore, it is mostly used for the small size products, because it is difficult to have the presses of the very large capacity. So, if we see here normally the 5 to the 150 million Newton press capacities are normally used, but these can be much larger up to like say the 600 million Newton capacity. So, it is the capacity that limits the size of the job which can be handled by the forging press forging, because very large capacities of the presses are required for press forging for the large size job. Therefore, the press forging is limited to the small size products. Coming to the machine forging. Machine forging is basically this has been used for the upset forging processes mainly, like in case of the head of the bolts. for making the head of the bolts, machine forging has been used extensively. Like we have the bolt having the threads like this. So, at the top if we need the bolt, we need to offset and make the head like this. So, for making the heads, in case of the bolts, this process was initially used, and thereafter it has been used for making many other the products of the importance, like the axles, spindles, and number of the components having the like where upsetting is needed, and other products which use the one end is cylindrical or of the particular cross section, and other end is of the having the upset section. So, this may be of the different cross sections. So, for such kind of cross sections where one end is of the smaller cross section and another end is large. So, the machine forging is normally used for those purposes, and the axle, spindles, head of the bolts are the common examples of the machine forging products. So, if we see here the just for the comparison purpose, as I have said, the press forging and the drop forging. In press forging, uniform deformation throughout the depth, and the surface is more cleaner as compared to the drop forged products, because the drop forged products have the jarred impressions, and in a press forging suits for the smaller size component than the drop forging, because the capacity limits the size of the components which can be made by the press forging, because press forging needs a higher press capacity for deforming in closed impression dies. So, the press capacities normally range from say 5 to 50 million Newton for the normal applications, but this can be much higher for the special duty and heavy duty applications like 600 millions. So, as far as the machine forging, just as I have described, initially the machine forging has been developed for making the head of the bolts in continuous fashions, and advantage of this, it helps to regulate the flow of the grains in such a way that we can have the grain orientation in favorable manner, so that desired properties can be achieved. So, gear blanks, shafts, axles and the similar parts can be made by the machine forging, and the die sets which are used for the machine forging, which uses a die set where there is a die and there is a punch for heading the or you can say heading or punch or the heading tool. So, if we see here, this is the ram, this is the upper portion of the die, and this is the lower die, and this is the anvil, and between the two the job is placed. So, this is smaller cross sectional area in one end, another cross sectional area means increase in cross sectional area is achieved through the upsetting. So, that one end is of the larger cross section than the another end. So, these are the steps which are used where upset forging cycle is used, where movable die comes close to the stationary die to grip the stock, and so it is the process is very simple here, like this. This is the stock. So, this is the stationary die, and then there is a movable die. So, movable die is in this side. So, this will have the complication of the shape which is desired. It will be moved coming closer, and once the dies are closed, the flow of the metal will be taking place. So, as it moves, the dies will close gradually. In meantime, the stock will be upset, and the flow of the metal will facilitate will be occupying the will be following the path of the internal surfaces of the die cavity. So, this is what is achieved. The movable die comes closer to the stationary die with the grip to the stock, and the two dies in closed positions form necessary impression in the die cavity. Necessary die cavity form the necessary die cavity, and the punch upsets the stock until fill the die cavity, and after upsetting, punch moves back to its position and movable grips movable grips release the stock. So, this is similar to the drop forging. Upsetting operation is carried out in the number of stages as per the required complexity of the shape, and the stock material is removed from one stage to the another in proper sequential manner. So, as per the complexity of the shape, different kind of the different stages can be followed. So, these are the different products which can be made having the one end of the smaller cross sectional area than the other end, and these kind of the shapes can be made easily using the machine forging process. So, now there are few more things related with the forging process. Since the forging is carried out at the high temperature, invariably it is hot working. So, high temperature leads to the like say 1000 to the 1200 degree centigrade, at which the deformation is facilitated, followed by cooling to the room temperature. So, this involves a lot of shrinkage. So, the shrinkage is kept in mind, and for this purpose normally the shrinkage allowance is given. The second aspect is the die wear allowance. We know that the dies will have to work at high temperature and under the high pressure conditions. So, the die surface is wear out gradually, and to take care of that wear of the die surface, when the die surface will wear out, there will be increase in the dimensions of the job. So, that is also taken care of in the die wear allowance. And then there is one more thing which is kept in mind, that is the finish allowance. We know that if you want to have a very good surface finish, like 0.1 RA, which of course cannot be achieved through the metal working processes. So, we need to machine the surfaces. So, for machining purpose, for machining the components, we need to have the material. So, additional material is provided for the machining purpose, so that desired finish can be achieved, and for that extra material is provided by giving the machining allowance. So, these are the additional features related with the forging. Now, I will summarize this presentation. In this presentation, I have talked about the forging process, and there are two broad categories. One is upset forging, and another is drying out, means these are the two steps, and there are four types of the forging processes: smith forging, drop forging, press forging, and machine forging, and the variety of the products can be made with very good mechanical properties for the service of the engineering applications. Thank you for your attention.